So in the last unit, when we started talking about calculus, we defined velocity. And specifically, we said that the velocity is the change in position with respect to time. So we said that it was a derivative of position with respect to time. But I mean, that's a very functional definition, and it actually is what the instantaneous velocity of a particle is. But let's kind of look at a more intuitive understanding first, and see kind of what this means in a more physical, from more physical standpoint. So let's say we have some point A, and then we have some other point B. Okay, and so then there's A and B are separated by some distance, by some vector D. Okay. So something starts at A, it's going to end at B, but it has to get there. And so the first thing we would ask is, how long does it take to get there? So we say that we have a time t, and so there's it's going to go a distance d in a time t. So in other words, in this case, the average velocity, v average, is just the change in distance d over the change in time t, and that's all the average velocity is. Well, of course, to be the velocity, we also need to give a direction, right? So we say that this is in the d hat direction. So in terms of speed, though, it's just d over t. More appropriately, though, we would say that the average velocity is just the position RB, so R's position at B minus the position at A over the change in time that it took to get there. So of course, the faster we're traveling, so we see that if this is much bigger than the time, then we're traveling faster. So we're going to cover the same distance in a smaller amount of time. And that's all velocity is really saying. In the next couple videos, we're going to look at two different ways that velocity can change.